corrode, right? So why metals corrode is corrosion is a primary means by which the metals deteriorate, right? अब ऐसा तो नहीं है कि यार कोरोजन अगर होना है तो इस मतलब कई लोगों में मिसकंसेप्शन रहता है दैट कोरोजन ओनली ऑकर्स corrosion only occurs in presence of some liquid electrolyte. This is a very, very wrong statement, right? Corrosion only occurs in presence of a liquid electrolyte. This is a very, very wrong statement. Most of the people have this misconception that okay, fine, like if a liquid electrolyte is present in the system, then only corrosion will occur. No, electrolyte can be in the form of solid also. Electrolyte can be in the form of gas also, right? And if it is happening in presence of a liquid electrolyte, specifically water, then a separate branch in corrosion. It is a separate branch of study called specifically the aqueous corrosion, right? But this, please, guys, don't have this misconception that corrosion only occurs in presence of a liquid electrolyte. No, corrosion can occur even in presence of a solid electrolyte. Corrosion can occur even in presence of a gaseous electrolyte. Okay, so my food for thought for today's class is food for thought will be, can you give some example of gaseous electrolyte? Some example of gaseous electrolyte, right? So I mean, you can WhatsApp me on my number, or if you want, like you can tell me at the end of the class also. But this job I want you guys to do. Okay, so give me an example of a gaseous electrolyte. Okay, anyways, so we will move on to our next thing, that see, whenever we talk about metals, most of the metals, they corrode in contact with water or moisture or acids, bases, salts, oil, aggressive media, anything, right? मतलब केमिकल, अगर मैं केमिकल सॉल्यूशन की बात करूं तो केमिकल तो कुछ भी हो सकता है ना. uh, you know, even like metals, they also corrode in presence of gaseous materials. अभी gaseous materials बोले तो क्या? For example, suppose if I take a pipeline, right? अब उस पाइपलाइन में मान लो मेरा जा रहा है अमोनिया गैस. Suppose if ammonia gas is flowing through that pipeline, it's a steel pipeline, right? It's a steel pipeline. So will it corrode? The answer is yes, definitely. It will corrode, right? And what is the reason? The reason is because the constituents of the ammonia gas, they have the ability to react electrochemically. They have the ability to react electrochemically with iron which is present in this steel, right? So that's why in any system where one of the component has the ability to react electrochemically with another component, in which jahan pe, whether it is the both are in direct contact to each other or they both are in contact through a electrochemical through a electrolytic media, right? So in those cases corrosion will occur. Now, you know, the oxide, एक थोड़ा सा मतलब ऐसी एक डिस्कशन है, मतलब उतना इंपॉर्टेंट नहीं है, बट आप इंटरव्यूज वगैरह में जब आप जाओगे तो उसके लिए इंपॉर्टेंट है. The oxide, the naturally forming oxide on the surface of the metal, the naturally forming oxide on the surface of the metal, this also acts as a solid electrolyte. What is the reason? भाई अब आप कहोगे कि सर सॉलिड मेटल ऑक्साइड और इलेक्ट्रोलाइट की तरह एक्ट कर रहा है, ये थोड़ी बात हजम नहीं हुई, कोई बात नहीं, मैं हजम करवाता हूं, ठीक है। सो हाउ दिस naturally occurring oxide is acting as a solid electrolyte is because, you know, these metal oxides are either act as a n type semiconductor or a p type semiconductor. See, using the word semiconductor is wrong because these naturally occurring oxides, the conductivity of these naturally occurring oxides do not match the level of the semiconductor materials that we know of in the whole periodic table. But just for your reference, I'm talking that these naturally occurring oxides, they can either act as an n-type oxide or they can act as a p-type oxide. Okay, okay, good. So now, see what is happening, like when does a this metal oxide act as a n-type, or when does a metal oxide act as a p-type? So like, can anybody unmute yourself, like think for 2 minutes, ठीक है, आप 2 मिनट तक सोचो, and if you get with the answer, just tell me. Like, this is an open question to all the members who are present here. Can you tell when does a metal oxide will act as an n-type oxide, and when does a metal oxide it will act as a p-type oxide? Anyone? Come on guys, I'm waiting. मतलब कुछ तो एक वेग आइडिया होगा ना आप सबके पास, कि मतलब एन टाइप क्या होता है और पी टाइप क्या होता है, या दिस
Yeah.
या टेल.
When the free electron is there, then we can consider a n-type, and when the um, uh,
Mm-hmm.
positive positive charge carrier is there, then we consider a p-type. Sorry, if the free electron is there, then we consider n-type, and the holes is considered just like positive charge carrier more, then we consider p-type.
Mm-hmm. Okay, so let us, okay, fine. Your explanation was correct. Now let us say I'm taking the example of zinc oxide. तो जो zinc oxide होता है वो एक N type है या P type है? Okay, I'm telling you the answer. Zinc oxide is a N type oxide, but why? Why? Can you tell me? Whoever just responded now. You said ना that n टाइप में एक्सेस आपके इलेक्ट्रॉन्स होते हैं, तो क्यों ऐसा, लाइक मैं कह रहा हूँ, दिस इज योर आंसर, जिंक ऑक्साइड इज अ एन टाइप ऑक्साइड, नाउ आई वांट यू टू स्टेट द रीजन व्हाई इट इज कॉल्ड अ एन टाइप ऑक्साइड.
Because it is more active and it has the more free electrons to react.
प्लीज. तो ये फ्री इलेक्ट्रॉन्स कहाँ से आ रहे हैं? ये फ्री इलेक्ट्रॉन्स इस तरीके से आ रहे हैं कि जो जिंक ऑक्साइड होता है, इसमें बेसिकली बहुत सारी ऑक्सीजन की वैकेंसीज होती हैं, राइट? ऑक्सीजन की वैकेंसीज होती हैं. अब द नेक्स्ट क्वेश्चन अराइजेस दैट फ्रॉम वेयर डज दिस ऑक्सीजन वैकेंसी केम? The oxygen vacancy basically comes from the fact that the naturally occurring metal oxide is not stoichiometric. Okay, it is not stoichiometric. I guess the spelling of stoichiometry is wrong. Okay, sorry. Uh, this metal oxide is not stoichiometric. Okay, so what's the reason behind it? The reason is simple, that it is a natural occurring oxide. So either you can have excess of metal cations. There might be four cases which is possible, right? Either you can have excess of metal cations, or you can have uh, deficiency, or you can have a deficiency of metal cations, right? I mean, these all are a part of uh, these all are electrochemical aspects of corrosion, but you must also know this, right? Or you can have excess of oxygen, or मतलब oxygen मतलब क्या, excess of oxygen, yeah, in short, excess of anions, or you can have deficiency of anions, right? So these are the four cases which can arise, and like these will determine whether my metal oxide which is forming, it is of N type or P type, right? See, some of the examples of N-type or P-type oxide, if I tell you, then okay, I like as we said, zinc oxide, it is a N-type conductor. Other examples could be, tin oxide. Tin oxide, it is also an example. These both are examples of N-type conductor. And talking about a P-type conductor, then you have this ZrO2. Like ZrO2 is a very important zirconium. It is a very important structural component in nuclear reactors, right? Other P-type oxide can also be uh, MgO, guys. MgO can also be, act as a P-type this conductor. Okay. Okay. Anyways, now, so this was about N-type metal oxide and P-type, just for a basic idea, right? So now what is happening is, the important question arises: how exactly a simple, right? How exactly, let us take a simple iron piece, right? We have a iron piece, है ना? सो अभी मुझे पता है, अब ये तो बेसिक सबको पता है कि जो एनोडिक रीजन होता है उसमें मेटल के कटायंस प्रोड्यूस होते हैं. सो दिस इज द एनोडिक रीजन, सो वी हैव Fe2+, and this basically electrons, the flow of electrons, right, from the anode to the cathode. And let's say it is surrounded by water. एक सिंपल सा एग्जांपल लेते हैं. इट इज सराउंडेड बाय वाटर. तो यहाँ पे आपके वाटर के जो H+ आयंस है वो आएंगे और ये इलेक्ट्रॉन्स के साथ रिएक्ट करेंगे और H2 बनाएंगे. ये सिंपल सा मैकेनिज्म है. बट हाउ टू डिस्क्राइब इट, राइट? द डिस्क्राइब इज दिस whole effect. If I talk about uniform corrosion, right, then this simple process of rusting of iron in the presence of water will occur in all the spots or in all the positions with equal probability. मतलब सब जगह होने के चांसेस इसके with grammatical mistakes. I hate it, but some of you who are doing their MTech or PhD, they know that how important are grammatical mistakes whenever you write a research paper or you post a MTech thesis. Okay, so positions with equal probability. And when I talk about localized corrosion, तो बहुत सिंपल है. Localized corrosion क्या है कि भाई these spots, right, these spots or positions, like, there are certain preferred sites. Where these spots or these positions of accelerated uh, electrochemical reactions will take place, right? So this is the basic difference between uniform corrosion and localized corrosion. So what are the other cases in general? What can be the cases? The cases can be like, suppose if you form a pit somewhere, right? or let's say if you form a crack somewhere, right? Or let's say um, these pits and cracks, what can be the sources of these pits and cracks? See, we know that dislocations, the dislocations, they cannot end anywhere, right? So if this is a metallic surface, and here if your dislocation is ending, है ना, if your dislocation is ending on a free surface, like this is a free surface of a metal, so if your dislocation is ending on a surface, then basically a step is created. So this particular area, it can form as a site where this localized corrosion can take place, or initiation of corrosion can take place. What can be the other sources? Other sources can be fatigue, right? If suppose the metal surface is experiencing fatigue, and a step is formed during um, loading, है ना? During cyclic loading, a step is formed on the surface. So this localized area, it can also act as a as a site for the initiation of corrosion, or as a site where localized accelerated corrosive attack of the species could happen, है ना? Okay. And let's say you have various corrosive agents such as seawater, है ना? Okay, so acha, now this is a question to again to you guys. In seawater, which is more corrosive, carbon steel or stainless steel? Come on, answer me. In seawater, which is more corrosive, carbon steel or stainless steel? Anybody, unmute yourself and tell which is more corrosive, carbon steel or stainless steel in seawater. Anyone? The answer is carbon steel.
Stainless steel.
Huh.
Maybe stainless steel because there may be lots of pit formation is there during.
Exactly. Yes, that's the correct answer. So in normal water conditions, definitely carbon steel will corrode more. But in seawater condition, this is the case that we have a diagram called E versus pH diagram. So if you see the E versus pH diagram, I'm just drawing a very rough figure, guys. Okay, like it's a rough figure just for your understanding. Okay, so in E versus pH diagram, we have to see, the oxide which is forming, the protective oxide scale which forms, it only forms under a particular combination of pH and electrode potential. If either of these factors are disturbed, then it is not necessary. That the oxide scale which is forming on the surface of the metal will protect it. Okay, there can be a possibility where soluble oxide scales might be formed, which will just cause eating away of the metal. ठीक है, तो हमें क्या देखना है कि भाई सोल्यूबल ऑक्साइड स्केल ना बने, कोहेरेंट ऑक्साइड स्केल बने, उसके लिए हमको थर्मोडायनेमिक्स ऑफ कोरोजन को बहुत बहुत लाइक ये किन कंडीशंस में बने, उसके लिए हमें थर्मोडायनेमिक्स, वी हैव टू अंडरस्टैंड द थर्मोडायनेमिक्स ऑफ दिस होल प्रोसीजर. ओके, so now it's just an interview question. It was asked to me in IOCL interview, what drives corrosion? How will you answer that? It's very simple, right? What drives corrosion? See, first of all, in any discussion about the mechanism of the corrosion, it is always advisable to separate the factors which determine the tendency or the driving force of that corrosive reaction. ये पहला फैक्टर आपको देखना है कि भाई आप दो फैक्टर्स को सेपरेट कर लो. एक जो उस कोरोजन, उस पर्टिकुलर फॉर्म ऑफ कोरोजन के ड्राइविंग फोर्स को अलग कर रहा है, और दूसरा विच इन्फ्लुएंस द रेट ऑफ द रिएक्शन। एक है ड्राइविंग फोर्स और एक है रेट ऑफ कोरोसिव रिएक्शन। तो